The presence of an actor on a blockchain happens through a public key, which is a 32-sign long alphanumeric string that is the equivalent of an account number. This public key comes with a secret private key, which is a 64-sign alphanumeric string that can be compared to a password and that serves to authorize or sign transactions. Both keys are generated outside the blockchain with a standardized key generation program. The public key becomes visible on the blockchain with its first transaction. Once present in the blockchain database, it is visible to everybody. As long as no first transaction has been made on that public key, it exists only outside the blockchain. The private key must be kept completely secret, as it is literally the key to your ownership. The interesting part here is that the public and private key are one-way mathematically linked, which entails that the public key can mathematically be extracted from the private key, but not the other way around. The standard key generation program is freely available in cryptographic packages and also on the internet under, for example, the website bitaddress.org. Here you see an example of a public-private key pair generated with bitaddress.org. On the left, you see the public key, which can be shared similarly as with your account number, and on the right, you see the private key, which must be kept absolutely secret. Let's have a look at how a transaction is authorized on the blockchain. Here, we see a typical transaction line in a blockchain database that holds the public key of the initiating party, the public key of the receiving party, the asset identification number, a timestamp, and a digital signature. Now, that digital signature authorizes the transaction. And to generate that digital signature, a signing algorithm uses two inputs: the private key of the initiating party and the content of the transaction itself. As the content of the transaction is never the same, a consequence is that a digital signature is unique for each transaction and can't be copied between transactions. Let's come back to that one-way mathematical link between the private and the public key. This mathematical link has the special property that just by using the public key, a digital signature's authenticity can be verified. Meaning that just by having the information held in the transaction, everybody in the network can confirm mathematically that the digital signature must have been generated by the person that knows the secret private key that goes with the public key in the transaction. See you in the next video.